Good evening,
My
one and all.
PPT.
Yes, sir. You can do it. Yeah. Good evening, one and all. Myself, Professor Naveen, Department of Civil Engineering, NITTR Kolkata. Today we have industrial expert Mr. Parvanjit KP is a managing director, Paradigm Environmental Strategy Private Limited. He completed BE in Civil Engineering and Masters in Geotechnical Engineering. He holds an executive MBA from Commonwealth. He is currently pursuing PhD in Municipal Solid Waste Management. He is also a lead auditor for EMS 14,000 and internal quality auditor of ISO 9000. He is a fellow Institute of Engineer, member Indian Geotechnical Society, fellow Institute of Valuers. Mr. Paramjit has over 32 years experience and he has completed 500 plus project experience in environmental infrastructure, wastewater management, renewable energy, climate change and allied fields. Managed projects in 11 countries and 27 Indian states. He was the technical consultant to the Municipal Solid Waste Management Manual 2016 prepared by the CPHWO, Government of India. He has been expert trainer on solid waste management for Compactor Auditor General of 8 countries. He has developed SWAP, a decision-making software tool for solid waste management for Swachh Bharat Mission, which is a part of MIS of Government of India. Several of his projects designed by him have gained a national recognition, mainly the special mention from the Honorable President of India under the National Urban Water Award 2009 for decentralizing wastewater treatment for school sanitation project, the decentralized STP for Kundanalli Lake Rejuvenation, Bangalore, won the first prize under the National Water Award 2018 from Government of India. The segregate waste accounts SCWAC, the real time of IoT based onboard waste weighing system, secured the best emerging innovative technology in solid waste management for collection and transportation from the Ministry of Science and Technology, Government of India, and the first runner up at the Smart City Competition 2021. With this introduction, now I request Paranjit to deliver a talk on innovative management of organic waste and fecal sludge through Co-Digester. Sir, now it's over to you, sir.
Okay. Is my screen visible?
Yes, sir, it is visible.
Okay. Thank you, Dr. Naveen, and thanks to IIT Kolkata for giving me this opportunity. Good evening to all. So this is about an innovative management of organic waste and fecal sludge through co-digestion. For people who are in this field.
Sir, excuse me, sir.
Yeah, screen managed.
I'm the technical from the technical team NITR Kolkata to this program. Sir, when you are sharing the PPT, one thing you can just off the annotation, sir.
Okay.
If it is possible, sir, if it is possible, then it will be means for the session it will be very good for us.
Yeah, no, but how do I stop it?
Okay, no, not required to stop it. You just a minute, hold on, sir. You go to the slide. Means when you are sharing, is there you are in the upper portion
with annotate.
Annotate, right? Then in the right side, more option is there.
Yeah.
Go to that
disable annotation.
Yes, disable that.
Thank you.
Thank you very much.
Visible?
Sorry?
Is the screen clearly visible?
Yes.
Okay. So I'm getting a different. My screen has gone.
Yeah, thank you, Abhijit. Nice instruction, nice guidance you have given. Sir, can you make it a bigger screen?
No, that is what I'm trying. Somewhere it just went.
I think you are sharing PDF. That's why, sir.
No, I somehow did not.
Make it a little bit bigger. Increase.
I know that is what I'm trying to do that.
Yes, sir.
The problem is I don't know, misplaced that PowerPoint file. So I downloaded from your mail and I tried to take it.
Okay.
Yeah, because I had no time. I just reached from office and I was trying to.
Yes, sir.
Yeah. Is it? Now the screen has gone, right?
No, sir.
Shit.
Sir, hello.
Yeah, tell me, please.
Sir, you just stop the
Yeah, I will just
sharing.
do, I'll just get that. Just give me a couple of minutes. I'll get that
No,
PowerPoint.
it's your time. Don't worry. You stop
Yeah,
the sharing first, and then
yeah.
you take some times and you just again share. And the same thing, if when you start, the same thing you just check that annotation is disabled or not, sir. Okay, sir.
Yeah, I'll do that. Wait.
Okay. Thank you very much.
1 minute. I've not got the presentation. It's the whole thing. Yes, now I think it's clear. Yeah. So just a brief introduction about our company. Naveen has given one small introduction. I am from Eco Paradigm. We are into research and planning, consulting, design, and like he said, we have worked in over 27 states and 11 countries. Our core areas are water and wastewater, solid waste, energy, and climate change. So you can see some of the places where we have worked. And some of our clients, including the World Bank, the National Mission for Clean Ganga, UNDP, Government of Kenya, and some of our private clients, good big names in their own sector, and some community clients. So these are some of our credentials and which we pride ourselves. I was part of the drafting of the Municipal Solid Waste Management Manual. We have developed the software tool for decision making for the Government of India, Ministry of Housing. Then the project which I'm going to talk about, the waste to energy plant at Nasik, the secured landfill at Karnataka and Goa. 2 awards one from the President, Honorable President, and one from the Ministry. And then study along with the Government of Germany for resource and climate protection. Yeah. So coming to this project, see, all of us know solid waste is a big issue in this country. And I've taken an example of Kerala, where I'm currently working. I'm leading the solid waste management regional facility project of the World Bank. It's a 2,500 crore project for the whole state of Kerala. So this was meant for them, but it is true for any state, any city. The solid waste is a big challenge. And disposal of land waste, when you don't process, you need huge landfills. Yeah. So to just put in perspective, India would need a landfill the size of a city of Bangalore. Bangalore is one of the largest city, about 800 square kilometers. And India would need a landfill that size. You can imagine what it means. And if you look at the other side, you have wastewater, which is untreated. Going in most of the cities, it is untreated. Very small percentage of it is about 20% as per CPCB. And even that treatment is not to a tertiary level. It is basically primary, or some cases, some secondary level. Very few tertiary treatment plants are there, of course. So India basically relies on septic tank and soak pit. And this septage, which is generated from the houses, are a major issue, which typically is being tried to be handled using fecal sludge treatment plants. And that is why you see many cities, many states, they're following that. So that's another big challenge. Then the third big challenge is this situation of power. Electricity is not available most part, and whatever electricity we get is from fossil fuel, the coal, and renewable energy slowly ramping up. But for a growing country like India, which has 1/5 of the world's population, power is a compulsory item, a mandatory requirement, and that needs to be generated somehow. So that's another one. And you will see everywhere you have power cuts, you have issues, and because of which other sectors get affected. So you see this article where power cuts is causing shortage of fodder, which causes affects the dairies. Hospitals are affected. children dying because of lack of power cut. Recently, there was an accident with when the DG set, the so-called backup DG set, did not work. Some newborns were dead. So power is a major issue. So if you look at all this, the solid waste, the liquid waste, the sewage or the septage, and then the power. These are three fundamental issues which any local body faces. And then the fourth issue is about money. The revenue is not so adequate. The type of taxes they collect is not sufficient for urban local bodies to take care of themselves. So most of the thing rely on state subsidies or central subsidies to that is why you see a gap between what is required and what is available. So these four problems typically challenge any city. Okay. Now, what the first three do is it has a bearing on the climate change, and the climate change itself has other issues which affect, which is basically irregular rainfall, either irregular erratic rainfall, maybe very heavy on one side, maybe drought on other side. So these are something which are caused due to climate change. And solid waste happens to be the single largest waste itself happens to be the single largest man-made cause for climate change. The other things being energy and fuel, of course. So solid waste is a large contributor to climate change, basically the methane and other things. Untreated bio waste does cause the climate change part. So if at all we do that, what can we do? I mean, we cannot stop producing waste. Of course, we can always rely on this refuse, reduce, a 5R principle or 7R principle to the extent we can. But once you have generated waste, what can we do? That's important. So can we mend our way for a better world? So here is where we present this co-digestion model. Like I said, in a city, typically you have this solid waste, the bio-organic fraction of the food waste, which is generated in a city, and the septage, which is also a challenging situation. Most cities, there's a challenge. Now, typically you can digest solid waste in a biogas plant and then generate gas and then do bio-CNG, whatever you want to generate electricity. These are possible. Similarly, with sewage treatment, you have host of readily available technologies, proven technologies, your ASP, your SPR, your MBBR, MBR. All these are technologies which require power to clean up our pollution. The pollution generated by human beings, we need electricity to clean it up. Now, the solid waste also requires power. If you go for, let's say, we are making compost, we need electricity, we need fuel. But if you are going for a biodigestion, then it is it at least generates electricity on the reverse and also avoids the methane generation. Now, both these projects are standalone projects, can be looked at it from a straightforward. Everybody does it, everybody knows about it. And both of them will require two different agencies doing it, two different projects, its own capex, its own opex. So this is what is required. But when you combine both this nuisance, both the waste together in a single project and try to digest in a single biodigester, that's when it's called co-digestion. And that serves as a very good innovative practice because you require a smaller footprint. The footprint required for, let's say, handling domestic wastewater is good enough to handle the solid waste also. And this is a case study which we did in Nashik. It's the first project of its kind. It was built on a public-private partnership. And that was designed for handling 20 tons per day municipal solid waste and about 10 tons of septic. So the key thing which you have to consider here, the management of septage is the focal, and along with that, in the same plant, we digest as much as possible the biodigest the organic waste. So we have a 20 TPD MSW plant, that is organic fraction, and 10 TPD septage. And since 2017, it's working. It is designed to generate around 3,300 kilowatt hours of electricity per day. So there's a 250 kilowatt generator combined with this project. So what you see there, if you can see my mouse, the blue color dome-like structure is the biodigester. And this is the waste processing area where the inlet waste comes. You can see a septage vehicle here. And the waste is picked up from all these public toilets. The septage is picked up from we have a calendar for that. Every day, two tankers load of septage comes here. And then along with that, we get about 20 tons of organic waste. This is handled in this plant. So, of course, I'll show you how it's done. And then that is digested in this biodigester. The gas generated is taken out through these pipes and it is flared in it's burnt in a generator, gas generator, and to produce electricity, which is stepped up and transmitted to the Maharashtra state electricity grid. Excess gas, if any, or when the generators under shutdown, is flared so that we don't allow methane into the atmosphere. So the input to this is 20 tons of organic waste, like I told you, 10 tons of septage. This is the summary. The whole plant is located on a small 0.6 hectare footprint. And due to the treatment, see the biogas generation and burning has a effect of offsetting almost 1,000 tons of carbon dioxide per year. So that's from a climate change perspective, it's a very good bonus for us. So how we started off was we did an inventory of all these sources for septage. We also did an inventory of locations which can give us very segregated food waste, basically hotels, prisons, institutions, factories, hospitals. We did an inventory of that. And we don't want to waste time doing segregation, because that is a major deterrent to biogas plants. If you get any contraries, it would not work. So what we do is we identified sources where we have reasonable chance of getting good, high quality segregated food waste. And the septage in a public toilet is straight away, it's available. So then we did a lot of model studies where we found out a good ratio, and we also predicted the type of gas we can get if we go with a 20 ton plus 10 ton septage. And after that, then we made the concept designs, what would come in this plant. Basically, it will consist of a hopper to put in the food waste, which will then shred it. There's a system of shredders. So it's shredded into 5 mm type of size, and then it goes into a food waste tank. So it's stored in a food waste tank. And while doing the shredding, we'll have to feed water. So we use treated water in the shredder. So then you get a food waste slurry. And that slurry is inspected, and then we add the appropriate quantity of septage. We sort of mix it in that optimal ratio and then feed it into a digester. And from the digester, the gas goes into the after undergoing dry scrubber process. It removes moisture and H2S. It goes into the gas engine to be burnt, and that gas turbine, and then you get electricity out, which is stepped up and sent to the grid. The excess gas goes to a gas flaring system, which will burn off all the excess methane. From the digester, you will have equivalent, the amount of digestate which comes out, which is equivalent to the input material. And that digested tank, the liquid from the digest tank passes through a solid liquid separator. After the solid liquid separator, the solids are put back into the digester again, and the liquid is taken into a holding pond and recirculated. So excess solids are dried in a sludge drying tank and composted and sold as compost. So this is what it is. These are some photos, including the toilet which is there in the plant. Is the wastewater from the toilet goes into our plant only. Then these are photos of the digesters. This is the digester tank has got a capacity of 1,500 ml. Yeah, 1 million liter. And in that tank, you have this, the storage of this liquid. And then the balloon is a double membrane balloon, which will fill up when the gas is present, and then you have the gas cleaning system and all other things which are linked to this. Sludge drying bed to take care of the effluent from the digester. Your lined pond to store the liquid which is collected, and it is used for recirculation. Generator room, the metering room, and the biogas plant. So this was inaugurated in 2017 end, and it received a lot of acclaim. I think including the president had come and visited and see this project. Yeah. Now the key part here, like I started with the initially, I said a ULB has three problems, which is the solid waste, the liquid waste, and electricity, shortage of electricity. So there are three problems. Coupled with that is a financial problem, which so managing solid waste is not so cheap. For the information of the audience, typically for a small urban local body, small corporation, small municipality, whatever money they earn, 40 to 50% of the money is spent on solid waste management. 40 to 50%, any city. If you are very big, still it's somewhere around 20 to 30%. Solid waste accounts for the maximum cost expenditure in an urban local body, which we don't know. We think it's street light and roads, but no, solid waste is the one which costs money. And all of us would not be satisfied with the work which a municipality does, even though we are spending so much. Electricity, street light, and other things, the municipality again spends money. So here, if you look at this project, on the left side, what you see is a business as usual. That is, if a city is spending money on doing solid waste management, using the conventional method, maybe a compost plant, maybe a biogas plant. So then the cost for the city is about 3,000 rupees per ton of solid waste. This is the cost for transportation and processing of the waste. 3,000 rupees is a minimum. It could be more. It could be 4,000, 5,000. Like in Bangalore, it comes up to close to 5,700 rupees per ton. So this is the cost on a business as usual. Now, a plant like this, 20 ton, 30 ton, this will cost you about 7.5 crores. But then what happens when I do a co-digestion? I am handling both the solid waste and the liquid waste, while you can see here the economics. I get electricity, 6 rupees I've taken. It's actually on the lower side. The cost for the this one is roughly, the electricity cost is now 8 to 10 rupees. So even if you take a lower side 6 rupees, the guaranteed electricity is around 3,300 units per day, which means on any single day, you get about 20,000 worth of electricity generated from this project. Okay, so 20,000 means about it is a 990 rupees per ton of cost is saved because of just electricity. So from 3,000, the effective cost, because you're getting electricity free, the effective cost reduces to 2,000 only from a municipality point of view. So you see, instead of spending 3,000, which is again on the lower side, by virtue of getting almost 1,000 rupees worth of electricity, their effective cost of solid waste management reduces to 2,000. Okay, so that is one side for the client. For the operator, if an operator is putting only solid waste, they will not get this type of money. What they end up is, instead of where they have an opportunity cost of 3,000, because they are doing this combined septage and solid waste, they get a margin of 783. That means they get an additional 35% income they get for an operator. So this is a classic case where neither the client loses money, in fact, he saves 30%, and the operator, who would have been otherwise doing only solid waste, by virtue of doing septage management also, with the same facility, is earning an additional income which gives them at least another 800 rupees. So both of them effectively get money with profits. No, that's the impact of this project when you do co-digestion. So although it's a technical project where we have done combining both the waste fractions, the investment being same, and you're using the same investment for handling both, which would have otherwise been double the cost. We see the ULB case 3,000 is only for solid waste. Had they considered bringing septage, that would have been additional 2,000 rupees. So it would have been more for the urban local body. In this case, the urban local body is saving 1,000 rupees. That's the important part. And for the operator, because he's handling both, he's getting another additional income, which effectively means it's about another 800 rupees. So this is the final photo when it was done, commissioned. What you see here is the process plant where we do some tertiary level of segregation just to see if, because it's food waste, you might land up with some broken cutlery or some spoons or something, which will unnecessarily add, maybe cause the pump to go into repair. So only for that reason, we do a screening. Otherwise, there's nothing much which comes out. Now, what does it mean if India tried to do this as a model solution for the cities which are not served right now, where solid waste is not fully compliant to the rules, where the septage is not being handled, where there's no FSTP. See, if it's already there, there's nothing much you can do about it. But if there are new cities which do not have or have not filled all the gap, then just expanding this project from an Indian context, what you can see in black is for the India from a status point of view, and the red is for Karnataka. Red is for Karnataka. So had India gone for a wastewater treatment plant for all and trying to comply with the law, then at least 33,000 million liter plant we have to have installed capacity. We should have that. STP would itself needed about 8,200 hectares of land. And to run the STP, you would have required 5.9 million units of electricity every day. And the process emission along with the electrical emission would have generated about 18,000 tons of carbon dioxide. This is Indian perspective. This is quite a huge number, but mind you, it is also for India, which means 1/5 of the world's population there. Now, had it been Karnataka as a state, Karnataka 5th largest state, Karnataka would have required 2,473 million liters of STP. Area would have been 620 hectares. And electricity would have been 500,000 units per day, and that would have generated about 1,378. This thing. Similarly, on the solid waste, had they tried to fill all the gap, 70,000 tons of solid waste generated every day. I'm talking only of the biofraction. That would mean the composting facility would have required about 1,000 hectares of land, the whole country. Okay, that management of solid waste itself would have required about 0.7 million units, and composting and other type of technologies for processing bio waste would have generated about 1,850 of carbon dioxide tons, okay, in a year, in a day. Now look at it from a overall perspective, because as an environmentally conscious nation, we would like to preserve our environment, and we would like to treat our waste, which has been generated by our citizen, totally under a business as usual case. We would have required about 9,200 hectares. It's not a small area, 9,200 hectares. Electricity about 6.7 million units. That means the electricity which you don't have and which is scarce. In that electricity, you need to divert about 6.67 million units to them, to this handling both the facility problems, which means there's an equivalent GHG emissions of 20,000 tons per day. That's the implication of the conventional way, the way we are going into this project. Now, if we go with the co-digestion model as a solution, then what will happen is, instead of 9,200 for India, that thing would reduce to 682. So you see here the previous scheme, you see the area is 9,235. Now it reduces to 682. Energy will reduce. You are actually generating, instead of 9,200 hectares, we would require only 2,100 hectares if you go with a co-digestion project. That means there's almost 1/4 of the land is required for putting a combined co-digestion system to solve the solid waste and the septage problem. Okay, electricity, instead of 11.5 million unit, which is needed if you are going on a traditional route, you will be generating electricity of around 1 million unit. So that means there's an advantage of 12.5 million. That means negative 11.5 plus 1 million extra. So that is what is the advantage you're getting because of putting a co-digestion project. And instead of generating almost 10,000 thing, you will get an 847. It's a sink. It just absorbs this emissions. Yeah. So that is what it means. So net to summarize, from a waste management perspective, I'm not saying this is the only solution. There may be other solutions also, but going out of the traditional way, looking at the problem as an opportunity, and looking at it from a solid waste problem, wastewater problem, electrical problem, financial problem. So instead of looking at it from a compartmental angle, look at it as a whole thing, a single construct. Which means you see this one single project is solving all your problems. Basically, your solid waste problem, your septage problem, your electricity problem, and also your financial problem, because it's saving almost 1/3 of your cost, which you would have otherwise spent on handling the solid waste. So this is about my presentation. I stop. I'm ready to take any questions if you have. Dr. Naveen, how much time do you have? Okay, 1 hour we took. No, half an hour. Okay. If anybody has any questions? Or generally on solid waste, if you have any this thing, I can answer.
I request participant, if you have any question, please interact with.
Now this bio-CNG is becoming a big strategic input for India, because the government of India is placing a lot of focus on generating bio-CNG. The good policies have come up. It is an important thing for energy security for India. So instead of looking at waste as a problem and trying to use conventional electricity, fossil fuel to solve it, you can actually generate useful fuel, which means we don't have to rely on our fossil fuel like coal, or import gas from Qatar or other countries, Ukraine and other places. This biogenic gas is very useful. It is compatible with the CNG. And third thing is, because you're using biogenic fuel, your net CO2 emission is 0. In fact, it's negative because you're not, there's an avoided emission from fossil fuel.
Hello, good evening, sir.
Yeah.
Good evening, sir. Very wonderful lecture. Sir, I have one query. That is, what would be the efficient technology to process these jumble-based biomass?
Come again. Can you be a little louder?
Sir, what could be the efficient these processing technologies to process this jumble-based biomass?
Jungle-based. Okay.
Jumble-based ones.
Yeah. So see, biomass, if it is something which can be degraded, that is ideal. This would be a good solution. In this, of course, you can always add heating elements and enzymes and other things and improve the efficiency. Okay, that is possible. But if you're looking at biomass, which is more lignin type of fiber type of content, then ideally, going for a refuse-derived fuel type of material is better. Because it's difficult to digest all this fibrous type of material. Easy to digest, biogas is the better process.
Sir, I mean jumble-based biomass. Jumble, like as you said, the fecal matter and other things. Efficient policies to remove the waste to process this waste efficiently.
Jumble meaning you are saying mixed biomass, is it?
Mixed biomass, the fecal matter and all things.
Yeah, that's okay. Fecal matter, see, you understand this co-digestion. We are getting fecal matter separately. If you're getting fecal matter already into it, it's good for us. Except from the hygienic point of view, how do you handle hygienically? See, if I get food waste, let's say there's a spoon and a broken cup inside that, I can remove it manually. Okay. Spoons, of course, you can use magnetic separators, but ceramics, you may have to remove it by hand. But let's say it's mixed with fecal matter, there's a little bit of hygiene issue which is coming. Otherwise, as far as the biodigester is concerned, it has no problem. It will actually love it. We are trying to add septage from outside. So if you have fecal matter mixed, absolutely no issue from a technology point of view. From the practical handling point of view, you have to look at it. Have I answered your query?
Yes, sir. Yes. Thank you,
Yeah.
sir.
Thank you. Any other questions?
If you have any other question, please interact or drop the question in chat box.
Yeah. Like I told you, you don't have to restrict it to this. Solid waste is my subject, so you can ask general questions also if you want. If you want to talk about wastewater also, I can handle, but that's not the topic for me. But if you want, I can handle. Dr. Naveen, these are students or faculty?
Sir, faculties.
Faculty, okay.
All are faculties.
Yeah, yeah.
Please fill your attendance. I request participant, please check your chat box. Please
How
fill.
is the situation in Kolkata, the waste management?
Sir,
Is it satisfactory?
no, sir.
No. So
No.
what technologies are used there? I know that there are all transfer stations and all, but what happens with the waste which is collected?
As you know, they are collecting, just they are trying to decentralize concept is there. And few ways they are sending to landfill for the manure.
Okay. So that is the issue. If you send it to landfill, you will get methane emissions and you can also get landfill fires. Okay.
Yes.
The methane emission is the most dangerous part because
Yes,
fire,
yes.
at least it burns the methane and makes it CO2. Not much of an issue as such. Of course, CO2 pollution is there. But methane, when it goes, it becomes 28 times more potent than carbon dioxide. So 1 ton of CO2 and 1 ton of methane is equal to 28 tons of CO2. So methane is more dangerous. So putting it to dump site or landfill without processing is a risky situation. Instead, if you can harness it by by controlled digestion and sucking of the gas from there, that will give you a alternate fuel which can be used to supplement your biogas LPG. These days, that is what is happening. GAIL, India, Indian Oil, all these people have got lines. And what we can do is we can generate the gas, either put it in cylinder and give it to them. And that is used for your automobile CNG, or you can actually inject it into the pipelines. You need a pressurizing equipment, and then 250 bars if you can inject into the line, and there's a meter and they pay you for it. And gas is paid by kg. So it's a very profitable business. So if you're making compost and you're struggling to sell compost, this is the ideal system, making biogas from waste. Now, biogas with septage, you are solving two problems, whereas you are also increasing the gas output. That is something which I think I did not tell you in the research which we found. If you do biogas on its own and septage on its own on digestion, and then try to add up the gas content, you will get a certain X amount of gas. But when you mix it together and co-digest it, your gas quantity is higher than X. So that's something which is important. That is the purpose of co-digestion. Otherwise, technically, you can have two biodigesters, one for solid waste dedicated, one for septage dedicated. Take the pipe and put it into and call it bio-CNG and generate electricity. But by mixing and doing, you are actually getting higher gas.
Sir, just I want to understand, you have developed one model that is segregate waste account, a
Yes, yes.
real-time IoT based onboard
Yeah.
waste weighing system. Could you throw
Correct.
some light, sir, on
Yeah.
this?
So that is, it is called Sevak.
Yes.
Sevak also attendant, but it also means segregated waste accountant. Okay. So what it does is like, I think in Kolkata, how is it collected? You have a auto rickshaw which comes to your house. How is it done?
Yeah, sir. Door-to-door collection is there.
Door-to-door collection is there. Auto rickshaw comes and stand in front of your house or in a corner. Everybody goes with their waste and gives it to them at a predefined hours, right?
Yes,
Now,
yes.
now what is happening in the solid waste management rule? They have told that anybody generating more than 100 kg per day is a bulk generator. Okay, and he need not be provided the services from the urban local body. Okay, that is one side. That's a legal side. But otherwise, we are talking that we want to reduce waste. No, that is the first principle in solid waste. Now, how do I know how much you have generated today? What are you generating yesterday? What did you generate tomorrow? How much you generated in a month? And how does it compare to Dr. Naveen or Mr. Tanvir? No, from how much do they generate? We don't have an idea. So what we do, we collect, the auto rickshaw collects from every house, and end of the day, when it's full, as per the trip sheet, it will go to the processing plant or the dump site. There may be a weigh bridge, if at all it is there. They will weigh and say, okay, after covering, let's say 800 house, we collected, let's say 1 ton of waste. That's all we have, or 960 kgs of waste. We don't know individually how much you are collecting, how much you are generating, or how much you are generating of bio waste, how much are you generating from dry waste. These data we don't know. So what we have developed is Sevak. Sevak is an IoT where the whole vehicle itself is a weighing machine. The whole, you can imagine a big, large weighing machine coming in front of your house. When you put your waste, let's say I put this plastic thing, it will say it is 20 grams. If I put this shoe brush, it will say it is 80 grams. So it is weighed when you throw. So you have an identifier. So it's like I have a metro type of thing. When I walk with my cart, it records my as me as a source, and it will say, okay, I put 200 grams. 200 grams recorded and put against my name. So what will happen is it will show the variation in collection from each house. Which means from an urban local perspective, I can tell, okay, in this road, the waste collection from 200 houses is only 100 kg, whereas in the neighboring road, 200 houses generating 400 kgs, which means I can give targeted awareness. I can also tell, see, today when I do a compost plant, nobody knows what should be the size of a compost plant. We just tell 400 grams per person and multiply and say, okay, we will have a 300-ton facility or a 600-ton facility. But when the waste vehicles go there, is it actually bringing its rated capacity? It is bringing more than the capacity, or it's less than the capacity? We don't know. Since we don't know input, we cannot quantify the output. We cannot say whether the plant is working efficiently. Efficiency is input and output has to be measured. There's no measurement of input because it's not very clear. So when you say, I will say deploy one auto rickshaw for 750 houses, let's say the 750 house, the auto rickshaw has a capacity to lift 1 ton. Maybe the 750 people are really doing their best and doing refusing, reducing, recycling, and they're probably generating only 100 kg. So your trip will stop at 750 house and go back with 100 kg instead of lifting another additional 900 kgs. So you cannot optimize because you don't know how much waste is generated at each house. See, when we have water line, we have water meter in every house. So from the overhead tank, when you release water, we know how much water is being consumed in this line. If there is an excess consumption, you know there's a leak in the pipe. All these things we get because we know individual decentralized quantification. Similarly with the electricity meter, we know these are the meters, these are the house which Pravinjit will consume. This is the meter electricity per month. Naveen consume this much per month. So we know how much electricity is consumed in a particular area, whether we need to supply more electricity, whether we need to put bigger transformer, bigger transmission lines, more transmission lines. All these things are available. But in solid waste, which is, I told you, 40 to 50% of a urban local body expenditure, We don't have any data. So understanding this, eco paradigm innovated and invented this particular Sevak solution, which in 2021 was adjudged as the best innovation in solid waste by the government, by the Department of Science and Technology. Same year, we also were adjudged as the best runner-up in Smart City Challenge 2021. In fact, we are quite happy we did not get the first prize. But the interesting part in that challenge was state government of Telangana got the first prize and the third prize, and we displaced them in the second prize. So you can imagine a large state government of Telangana got the first and third, and all other states did not get anything. And our Sevak won the second, that is a runner-up award. We also got the Smart City award from CII. So this is an innovation which it is actually in the UN best case. They say the best case is volume measurement from each house, but volume does not define waste. Waste is defined by weight. So this is an improvement over the best case in the UN. This thing, of course, it's not recorded as such, but this is better than the best model presented by UN. Yeah, that is about Sevak.
Yeah, thank you, sir. Just I want to know if you are applying this concept, you know that waste have been collected by the trucks. Again, when they are entering into landfill, they'll be doing a weighing in the weighbridge.
Yeah.
Can we validate that weight and this weight?
Yes. This is like your double accounting.
Yeah.
See what's happening when you are putting your money into your account. You are doing some expenditure on UPI. You are doing credit card. You are doing all that is getting reflected in your bank account, right? Similarly, when I do collection from each house, progressively on my computer, I know how much the auto rickshaw is getting filled up. Okay. Now, let me see after this. If I have time, I'll show you that actual working thing. Of course, you won't see the auto rickshaw moving because it is collection is not happening now. But morning, it usually you can see that. Now, as you collect, see, there's a thing called overloading of an auto rickshaw. Mechanically, you should not overload a vehicle. Now, let's say today I'm cleaning my house, I'm shifting my house, and suddenly I generate about 200 kgs of waste. All that I'm going to put in my auto rickshaw, which comes to my house. So next house, let's say they are also shifting the house, that's 300. Fourth house, 700 kgs over, 1 ton is over already. So the question of trip continuation does not occur. The auto rickshaw has to stop there and come back and go to and clear it and come back and start processing, right? This thing does not happen in the city because we don't know how much waste everybody is giving. That is why you see overloaded auto rickshaw spewing black fumes and also waste falling out as it goes. So with this, you can really track. And as it goes, now let's say my auto rickshaw is filled up, there are 763 kg is there in the auto rickshaw. I go and give it to the compost plant or whichever plant. When they take it, 763 is taken away. Here it will become 0 because it has become empty. So I get a double accounting of waste. So this is quite important because in many places, what's happening? Plastic, the government has set up plastic recycling facilities and other things, which is actually, it is a revenue for the municipality. Now, let's say I am a corrupt contractor. I collect waste and I see a lot of good plastic and steel in the thing. I take it and somewhere I stop and I take that steel and plastic, keep it on the side, go and give balanced material, maybe 100 kg less, I go and give it to the facility. The facility is handling a poor quality, less valuable material, whereas the costly material I have siphoned off. There's a leak and I take it out and sell it. So profitability of a solid waste management gets affected with this. So this double accounting is a very good thing. Now, third incident is, I told you 100 kg and above are not supposed to give it to the urban local body vehicle. Now, let's say the vehicle is going and there is a big apartment or a big hotel who's generating a lot of waste. Instead of, according to the law, he's supposed to put a decentralized waste management facility in their own hotel or in their apartment. What they do, they don't spend money there. They give some tips to the driver and just add that load onto the auto rickshaw. The municipality pays for this, that 3,000 rupees or 4,000 rupees, whatever it is. That fellow, by giving some 200 or 500 rupees lump sum per month, he has managed to dispose of his waste. Now, what happens in my system, moment I get a weight, it will show cumulative. So I will see 200, 200, 200, 210, 211, 212. Suddenly it becomes 300 or 340. I know that somebody has given me at that location, and I can actually investigate what is that. Let me see if I can show you that Sevak thing now.
You have
It's
the,
just loading.
if you have model, you can show the
Yeah, I
demo.
can show it is running in Bangalore, but right now it will not be. Yeah, this is the Sevak.
Please share the slides.
Okay, this is I get it on my end. No, anybody can see this. It takes some
Can you
time to
share the
load.
slides?
Is it not visible?
No, sir.
It's not a slide. It is an actual app.
Just we are unable
Are you
to.
seeing anything?
No, no,
You're not
no,
able to see anything?
no. You have to
Okay,
share
let
your
me
You can
screen.
share your screen, sir.
Yeah, I will do that. Let me see. First, let it load. It's just the problem is I'm using a hotspot. That is the reason.
This is an excellent innovation, sir.
Can you see this? Still loading.
Yes, sir.
Yeah. So this is the thing. Here, what you will see is a map and dots. You will see the map and dot of each house where it's located. Fortunately, the speed is not good. Let me save my video. Maybe it works.
Sir, this is an excellent innovation, I think. Sir,
Yeah.
are you also selling this to other governments and all?
Yeah, we are trying to sell to various governments. Unfortunately, we are not got. We just got now. Bangalore has bought a law which says that anybody who is producing 100 kg should pay 12 rupees per kg. Now look at the law. It has just come about 1 week ago. Now let's say I am an apartment. I am generating 120 kg. Okay. So as per the law, 120 into 12, 1,440 I have to pay. But how does the municipality know whether I given 120 or whether it's 63 or it is 95 or it is 250? They don't know because you
Right.
cannot wait. So with
Right.
this, when you transfer to this auto rickshaw, you will immediately know. And the data will
But
be
you'll
there.
have to actually sell it to the governments only, because
Yeah,
this is going to be useful
yeah,
only
it
to
can
the
be.
governments.
Yes, that's the whole thing because the waste is actually the problem. It can also do the fuel thing. So, some people, typical problem with government is auto rickshaws are stopped and they put pipe and remove the fuel. So that is something which can be seen. And let me see anything which, that speed is not sufficient. It's a live tracking. You get a live tracking of the vehicles. And when I go to each point and click on it, it will tell me this is the Pravinjith's house, no? Or it is Dr. Naveen's house. And then if there is a small icon, which I take it and keep it on that, I will know what is around that location. I can actually see the street view. So I will know whether the load of 100 kg has come from a house, or is there any hotel next to it, or there's any apartment next to it, or any hospital next to it. These things we can find. There's a small camera which can also see if people are putting the right material. No? So let's say it's a wet waste collection vehicle and you're putting plastic bottles and glass bottles and all, it can capture. So you can do that type of tracking. Penalizing also is possible. Unfortunately, yeah, it is not working. It needs little. It's not. It's not. And it will also tell. There's
So
lots
maybe
of
you
data.
can share the link in the chat box. Then we can try the link in the chat box for the app.
No, this requires a login password.
Oh, okay. Sorry.
Yeah. But with this, the good thing is I can analyze the behavior of a particular person. I can analyze the behavior in a particular street or a particular locality or a ward, and can also then do as a postmortem and see, yeah, you can see some data has come now. Can you see some data?
Yes, sir.
Yes, we can see that.
Yeah, so these auto rickshaw, the GPS location, all those things are visible. Total waste collected that day. What time they're collecting is there. You can see this is the second shift data, I think. 3 o'clock, 3:25. Each house, how long it takes, Even you can do a what you call time motion calculation here. Each house, how much is the transaction time? You can see there's about 6 seconds is the time required for this activity, each filling. Let me see if the map has come. Maybe the map takes some time. Map is something which is very interesting because you can see the route which the auto rickshaw has gone. It will also tell whether the auto rickshaw has deviated from its ring-fenced route. And in that table which I showed you, you can see where is the delay. You can also analyze. It's got an AI, so you can check where is the maximum stoppage. So that maximum stop could be many things. One, the driver has gone for some refreshment or something. Or it could be that it is some bulk generator where they're waiting for barrels of waste to be deposited. Or it could be a place where some leak is occurring. Leak could be in terms of diesel or petrol siphoning. It could be that some materials are being taken out or taken in. So all these things can be tracked. And the good thing is for a contractor, at the end of the day, he need not see whether there's any issue with the weighbridge in that place. He knows this is what I have deposited. That should record there. You immediately get a contradiction. Today, it is not like that. Let's say the weighbridge has a problem. You will have to believe that it is correct. Yeah, I think that map part is not seen. It's not coming. Still loading. It's still loading. That's a little heavy. You need a little high speed for that. Yeah, any other questions?
Yeah.
And I can do this in multiple languages. Basically, I can.
Sir, whether this app will help to avoid the dead kilometers?
Yes, because once you get this data, now you can analyze. No? See, the interesting part I'll tell you. Sometimes you will make a trip with some logic. You use GIS and all. But now, let's say the first 10 points are getting the 800 kgs. Okay, the vehicle has got 1 ton payload capacity. Now 800 kgs, then it is going to the balance 700 houses to pick up the balance 200 kgs. You look at a reverse case. You reroute it from the other side. You are picking up 2 kg, 2 kg, 2 kg, and then when it reaches the last 10 point, it is only 200 kg. Then it fills up the balance 800 comes out, which is better from a transportation point of view. Going light and picking up the heavy in the end is the better thing. Otherwise, you are picking heavy and moving along with a heavy payload all through the trip. So that is one thing you can do. And based on this, you can now optimize your trip. Right now, I told you, we go on number. If you look at the MSW manual, it says per auto rickshaw 750 houses. Now, whether the 750 houses generate waste, whether they're generating extra waste, we don't know. So we simply say, okay, take the number of houses, 7,500 houses, divide by 750, 10 auto rickshaw for that ward. Now, when you use this, you know, okay, in this route, we need 2 auto rickshaw. In that route, 1 auto rickshaw can cover 3 routes, probably. So you can do route optimization because you have the primary data with you. Right now, the primary data is not available to anybody. So dead kilometers you can remove. You can also decide where to place your next collection point if you want. Your transfer station, how is it done today? Today, transfer station is put in the centroid of the place, centroid of the geographical place. It's not centroid of the waste. Ideally, if you're putting a transfer station, it should be closer to the place where you're having higher tonnage. So that is not there. So we take, let's say you have a ward of, let's say 4 square kilometer, we'll put one in the center, geographical center, no? From GIS. But that is not the scientific way of doing it. It has to be centroid of the load, which is different. That load, yes, if you have the data, you can do, but the data comes from this type of technology. So now, Manipal Tata Medical College, it's a university in Ranchi. They are buying this. Some other decentralized people, green campuses, they are trying to buy this because this will give them a lot of relevant data which will be useful for decisions. Basically, end of the day, it will cost you hardly anything. If I show you the economics, it will just mean what 1 rupee per house per month is a type of economics to put this fitment. Just is as cheap as that, 1 rupee. But that 1 rupee tends to save money for the ULB. It's a huge saving.
Yes.
I think I'll quit this because it's not loading. So I'll get a list of vehicle, who is the driver, and again, whether to collect 800 kgs, whether a particular driver is very efficient, whether there's any fuel consumption which is extra. When I change the driver in a particular route, does the fuel consumption increase? All these type of analytics I can do. So there's lot of, okay. There's one question, does a biodigester need any kind of microbial inoculum? Not necessary, because the septage itself brings a whole lot of microbes. It's not at all necessary. The septage is the tank itself is about 1.5 million liter. It's a big tank. And in that, when you put 30 tons of 20 tons of solid waste and 10 tons of septage, every day you're getting inoculum. Of course, one more thing which I did not tell you is from the generator, we are also taking waste heat recovery we are doing. And that heat is pumped back to the digester to give it a higher temperature. And higher temperature, as you know, in biodigestion is very good because it accelerates the microbial activity. Any other questions? Just ask anything, don't hesitate.
Sir, as a waste management expert, how you will address the Ghaziapur, Mawalipura landfill, Okla?
No, yeah. So on that, see, that's a legacy dump site.
Yes.
So it's not a landfill, it's a dump site. Now, I am right now handling 20 dump sites in Kerala.
Okay.
Our target is to make it a dump site free state by March. It will go until May because rains have continued, so we could not start. We have started the work very late now because all this fungal and all those things. But otherwise, it's nothing but a dump site job. So what we have to do is you have to do biomining. You have to remove the waste, and maybe it has some amount of organics. So that organics needs to be degraded. But if the dump site has been stopped deposition by, let's say, 3 years, 4 years, then technically all the organics have been degraded over with time. Okay, so if it is a freshly dumped type of dump sites, then we need to have windrows, and then you might need to spray some inoculum to accelerate the composting process. Then you have to do exactly what we do in compost. Basically, pass that material through a trommel, which is nothing but a circular sieve, a rotating sieve, and sieve out all the fractions. Basically, you can have compost fraction, you can have a soil fraction, you can have a burning fraction, that is a combustible, non-recyclable fraction. Any recyclables, you can do manual sorting and remove it. That will anyway go to recycling industry. Non-recyclable combustible fraction is taken out, which is baled and sent to cement plants or waste to energy plants to convert into refuse-derived fuel. Cement plant, many cement plants have the facility to burn it as co-incineration. It is a technology which is promoted by the government of India. Then the compost fraction, if there is compost, which means the compost has to fulfill the quality norms specified by the fertilizer controller order. So FCO norms, it has to fulfill. If it is fulfilling, it is a compost, we can sell it. If it's not fulfilling, then if it is marginally passing and failing and things like that, then we can use it as a natural soil conditioner or a soil improvement material. But if it is mostly inert, let's say only 20 or less than 20% is organics, rest is all inert material, bearing soil, stones, glass, and those type of material, they can use for backfilling. So this is what is used. This is what is to be done.
Sir, I have one more question, sir.
Yeah.
The inorganic material you mentioned, inert material, can we use it as a filter media for wastewater treatment, sir? Whether it contains heavy metals, it will interact with the water, again it enter into the wastewater, sir.
Yeah, yeah. See, yeah, when I say inert or compost, basically it has to meet the compost norms. When I say there is a check for heavy metals in that. If it's passing its compost, if it's not passing, but still within a certain level, there's an hazardous level also. At a hazardous level, it has to go to hazardous industry. Otherwise, it can be used for soil filling. No, if you are getting inert as in stones type, if you are able to segregate that, we can do that. All you need is to have density separators and those type of things. Then those things with washing can be used. If you're sure it is inert, it can be used as a filter material. But the problem is, it is little more expensive to make it into a sort of a water treatment type of material. Because we don't know the origin and source it's a dirty type of stones.
Wastewater treatment, sir, actually. Water treatment.
No, even in wastewater, because see, the stones can also dissolve, it can leach, a lot of things may be there. We'll have to see. It might physically look like a stone, it may not be a stone. So there is some amount of quality control to be done, but if you are sure it is a granite or that type of material, of course it can be used.
Yes, sir.
Quality control will be the key aspect. And I think that will be more expensive than buying material.
Okay, thanks.
Finally, I want to understand what about the plasma gasification, sir? Because we are facing the segregation problem. Okay, after giving guidelines also, somewhere in the primary or secondary, again that mistake is carrying out, mixing the waste. Instead of going with the plasma gasification, this problem like a Mavalipura, Ghaziapur landfill problem can be resolved. But why this technology is not implemented till now?
No, it's not like that. It's not a question of plasma gasification or anything. See, we have only three types of, you have the, either the pyrolysis, you have the gasification or the incineration, mass burn incineration, or you have the plasma. The plasma gasification is a marketing terminology. Plasma is a high temperature one, 4000 degree plus. Gasification is a lower temperature one. Okay. Pyrolysis is even lower. Incineration is 1000 degree plus. Now, what happens? The only difference is this oxygen part of it. Pyrolysis is oxygen starved, gasification is oxygen neutral, and then the incineration is uncontrolled oxygen. So that will be plus. So this is all what is happening. But all said and done, the SWM rules recognize only segregated, non-recyclable, combustible fraction to go into any incineration projects. All these are incineration, various types of incineration technology. Plasma by itself is not very proven. It's quite expensive, very proven. It's not very proven. So that is where it stops. It's quite expensive. It's not very proven. But if you are allowing burning, then all these technologies are available. But the only thing is burning non-recyclables only is permitted. And biodegradable should not be burned. That is a law, legal point of view. So although we know that in the fractions, you might have mixture, that is because you are not enforcing correctly. Just because you are not enforcing, it's like saying people are not wearing helmets, so let's have a lot of head injury hospitals everywhere across the street. Whoever falls down and breaks his head will take it to the hospital. That is not the way to solve the problem. Problem is to solve it by enforcement and solve it from primary aspect. There are two reasons. Yesterday was International Soil Day. India, like any other country, is deficient of soil carbon. So burning organic material is a crime because it has to definitely go to the soil and it has to be in the soil so that the food cycle is kept normal. If you burn away all carbon, then you are converting it to CO2, and that's the end of the thing, and you don't get food. So soil carbon can be got from city compost, which means organic fraction has to be converted to compost and then routed back to agricultural field. So citing the excuse that people are not behaving does not mean anything. That is a clear case of enforcement, because it's illegal from the law point of view. It is non-technical from a technology point of view, and it's non-sustainable from a sustainability point of view.
Thank you, sir.
Thank you.
I request participant, please fill your attendance. If you have any doubts, please interact.
Any other questions you have?
I think. Okay, sir. Then it was a nice interacting with you, sir. And
Thank you. It's a pleasure always.
And
Yeah.
it
You
was
can always reach out to me. Dr. Naveen has my email ID.
Yes, yes,
You have
yes.
any- Yeah. Yeah.
It was nice.
Okay. All the best. Thank you. Good night.
Thanks a lot, sir. Your presentation was
Thanks.
very
Thank you.
informative. It was nice to
Hello,
know you have
dear
applied.
participants.
Yeah.
Yes, yes, sir.
We are from the technical team NITER Kolkata. We have an announcement, sir. Hello.
Yeah, please go ahead. Abhijit, go ahead. Are you there?
In the link.
Can I exit?
Yes, sir. You can exit, sir.
Yes,
Thank you,
yes,
sir.
sir. Yes, sir. Yes. Hello, dear participants. Anybody in the link?
Yes, sir.
Yes,
Yeah.
sir.
Yes. One announcement from our side, from NITER Kolkata. Actually, based on the attendance we have receiving, your email ID we have received over there. So we are going to send one email to you regarding the training need analysis of the NITER Kolkata program that we are going to organize throughout the year as SCTP and FDP. Okay. So that TNA, this is nothing but a Google form. This shows the requirement of the participants all over the country, in which field they need, or in a particular college, what is the requirement for the upgradation of the faculty members and the staff members. Based on that, they can put their input and submit. So that link I'm going to share in this Zoom link here also, and I also send it to through email tomorrow. Please positively, as per your requirement, you fill that Google form. Thank you very much.
Okay, sir. Thank you.
Okay.
Sure, sir.
Yes, sir.
Thank
Okay,
you.
sir. Thank you.
It's a wonderful initiative.
All are requested this to do that. Like the attendance, you please do this form, fill this form again. Okay. Thank you. In the second session also, I will give it. Second session also, I will give it. Okay.
Okay, sir.
Thank you.